In this video, we are going to talk about how we evaluate double integrals with constant limits and with variable limits. Let us begin the discussion with how we evaluate double integral with constant limits. See the first one. Suppose I have integral a to b, integral c to d, then we have a function dy dx. If it is dy by dx, then what I do, I have to integrate the function first with respect to y. Then the result again we have to integrate with respect to x. Suppose if it is vice versa, say for example I have dx dy, then first time we have to integrate with respect to the variable x, then the result again we need to integrate with respect to y. Also you need to remember, when all the four limits are constants, that is a, b, c and d, all the four limits are constant, then we can change the order of integration as we like. That is, if I can integrate dy dx or I can integrate dx dy. But remember, provided the x limit should be in terms of x and y limit should be in terms of y, then we will get the same answer. Let us discuss some problems to make it more clear. Question number 1. Evaluate integral 0 to 3, integral 0 to 2, 4 minus y to the power 2 dy dx. So here, this is the innermost integration dy and this is the outer integration dx. So that means I have to keep the outer integral 0 to 3 as it is. Take the function, integrate with respect to y. So integration of 4 will give you 4y, integration of y power 2 will give you y to the power 3 by 3 between 0 to 2. Still we need to perform dx, so keep dx as it is. So this is 0 to 3. Replace the upper limit 2 in place of y, so that will give you 8 minus 8 by 3. By substituting 0 you will get 0, so we have dx. By simplifying this, I will get 24 minus 8 by 3 times dx. So this is nothing but 0 to 3, 16 by 3 into dx. Now I have to integrate with respect to x, so take the constant 16 by 3 outside. Integration of dx will give you x between the limit 0 to 3. So the final answer is 16 by 3 times 3. By cancelling 3 and 3, we will get 16 as my final answer. Let us move to example number 2. So here we have the inner limit is dx, the outer limit is dy. So I have to keep the outer limit as it is. Integrate the function with respect to x, that will give you x, plus integration of 8x will give you 8x squared by 2 between the limits 0 to 3. Still we have dy. So we have 1 to 2, apply the upper limit 3, so that will give you 3, plus this 2 and 8 cancel, we have 4. So 4 times 3 power 2, which is 9, so that will give you 3 power 2, which is 9. 9 times 4 will give you 36 into dy. So let me take 39 outside. Integration of dy will give you y between the limits 1 and 2. So this will give you 39, upper limit 2 minus lower limit 1. So the final answer is simply 39. Example number 3. So here the outer limit is 0 to 1. This is my function. I have to integrate the function with respect to y. So keep x as a constant term. Integration of y power 2 will give you y power 3 by 3 between the limits 0 to 2 and dx. So this will give you 0 to 1 x. So replace y by 2. So 2 power 3. 2 power 3 will give you 8 by 3 into dx. Then I have to integrate with respect to x. So take the constant 8 by 3 outside. Integration of x will give you x squared by 2 between the limit 0 to 1. So this will give you 8 by 3. By substituting the upper limit, we will get 1 by 2. Substituting lower limit will be 0. So the final answer 8 by 6. Further simplification, I can say the answer is 4 by 3. Example number 4. Again, here the first integration is with respect to x. The second integration is with respect to y. So keep minus 1 and 1 as it is. Integration of 1 will give you x. See the second term. In the second term, minus 6 and y is constant. integration of x power 2, that will give you x power 3 by 3 between the limits 0 to 2 dy. So this is minus 1 to 1, x minus 3 and 6 cancel, will give you 2y x power 3 between 0 to 2 and dy. So let me substitute the limits. So in place of x we substitute 2, so this will give you 2 minus, here we have x power 3, so 2 power 3, 2 power 3 is 8, 8 times 2 16, so we will get 16y into dy. Now I have to integrate with respect to y. Integration of 2 will give you 2y. Integration of 16y will give you 16y power 2 by 2 between minus 1 to plus 1. So this is nothing but 2y minus 2 and 16 cancel. We have 8y power 2 between minus 1 to plus 1. Now substitute the upper limit. So that will give you 2 minus 8. Then substitute lower limit. Before lower limit we put minus. If I replace y by minus 1, that will give you minus 2 and minus 8. So this is nothing but 2 minus 6 will give you minus 6. Minus of minus 2 minus 8 will give you minus 10. This is minus 6 minus minus plus 10. Minus 6 plus 10 will give you 4. Question number 5. As usual, keep the outer limit 1 to 3 as it is. Take the function, integrate with respect to x first. So this will give you x squared y by 2 plus 5x to the power 3 by 3 between the limits 0 to 2 into dy. So again we have to keep 1 to 3. Replace the upper limit 2. So 2 power 2 will give you 4. 4 by 2. 1 2 get cancelled. We have 2y. Plus if I substitute 2 for the next term, 2 power 3 will be 8. 8 times 5 will be 40. So I have 40 by 3. This all into dy. So next I am going to integrate with respect to y. So the first term will become 2y power 2 by 2 plus the second term will become 40 by 3 into y 1 to 3. Then if I substitute the upper limit, that will give you 9 plus 40 minus, if I substitute lower limit, that will give you 1 plus 40 by 3. So this will be 49 minus 1 minus 40 by 3. By simplification you will get 104 by 3 as the final answer. Now we are going to talk about how we evaluate double integrals with variable limits. When you deal with variable limits, you need to be careful. So as I said, here we have a, b, c, d. Okay, here you have some function f of x comma y. Suppose if I have dy dx, then what is the meaning? First time with respect to y we need to integrate, second time with respect to x we need to integrate. Always remember the outer limit, this one a and b, it should be always constant. The inner limit c and d, it may be constant or it may be variable. If it is variable, it should be the opposite variable of the integration. For example, here we have dy. So what is the meaning of dy? I need to integrate with respect to y. So if you integrate with respect to y, then the corresponding limits, that is c and d, this either constant or in terms of x, something like x or x power 2 like this. Remember, there is no y should be here in place of c and d. Okay, what will happen if I have like this dx dy double integral? Then as I say, the outer limit is always constant. Here the order of integration is dx. So here you have either number or you have something like this y. Here you have number or you have something like this y power 2. Remember, if the innermost integration is dx, then the corresponding limit should not be in terms of x. It should be in other variable. Let us see this example. So here we have 0 to 1 and this is my function. My order of integration is y first and x second. So see the limits here. The limits, one limit is 0, other limit is other variable. So the form is correct. So I have to integrate every term with respect to y. So this will become 3y second term will become minus xy, third term will become minus y squared by 2. This between 0 to x, still we have to perform dx. So 0 to 1, if I substitute upper limit, will give you 3x minus x squared by 2 times dx. Lower limit will be 0. Now I have to integrate every term with respect to x. So I will give you 3x squared by 2. Second term will become x to the power 3 by 3. Third term will become x to the power 3 by 3. We have already 2. So 3 times 2, 6. Between the limits 0 to 1. If I substitute the limits, will give you 3 by 2 minus 1 by 3 minus 1 by x. By taking 6 as the common number, we have 9 minus 2 minus 1. So this will give you 6 by 6. So the final answer is 1. Let us discuss one more example. Integral 0 to 1 x and root x squared plus y squared into dy. So here this is my function. I need to integrate with respect to y. So keep the outer constant limit as it is. Integration of x power 2 will give you x power 2 times y, plus integration of y power 2 will give you y power 3 by 3 between the limits x and square root of x and dx. So this will become 0 to 1 x squared square root of x plus square root of x to the power 3 divided by 3 minus, if I substitute lower limit, this will give you x to the power 3 plus x to the power 3 by 3, this all into dx. So now we have 0 to 1. The first term will become x power 5 by 2. The second term will become x power 3 by 2 by 3. And this will simplification will give you minus 4x to the power 3 by 3. So these three terms we have to integrate with respect to x. So the first integration will give you 7 by 2 upon 7 by 2. Integration of second term will give you x power 5 by 2 divided by 5 by 2. We have already 3, so 3 multiply 5 by 2. For third integration, this will be 4x to the power 4 divided by 4. You have already 3 in the down, so that will be 12. So these things I have to replace 0, 1 and 0. So before substitute, let me rearrange this one. So here this 7 by 2 will become 2 by 7 x power 7 by 2, plus in the second term this will be 2 by 15 x to the power 5 by 2 minus x power 4 divided by 3 between the limits 0 and 1. Okay, now if I substitute the limits, this will give you, the first term will be 2 by 7. That means I am replacing x by 1, plus the second term will be 2 by 15. The third term will be 1 by 3. By simplification of all will give you 32 by 3 as the final answer. So here are the questions for you to practice. See you in the next video.